In this lesson, we'll talk about units, metric prefixes, and derived unit. For each quantity, we have an SI base unit. And these are the units that are agreed upon that if we're going to talk about the mass of something, we're going to talk about it in kilograms. The length is always measured in meters. It's not to say that other units can't be used, but we use these units when we're trying to communicate across states, countries, continents, because if we're all talking about the same value with the same units, it's much easier to make those comparisons. Now, the first five are the ones that you'll see most often. So length, mass, temperature, time, and amount of substance. There are also two base units, which are current and intensity, but we won't get into those in this course at all. These are the universal standards, so that way everybody is talking about the same quantity in the same units. We'll also see what are known as derived units. And derived units are basically when we put two or more units together to mean something else. Now, if they are based on their base units, if we're talking about area, which is length times width, so two distances, the base unit of length is meters, so our base unit for the derived unit would be meters squared. We see something similar for volume, where we have meters cubed. And the other one we talked about is density. And officially, the base unit for that would be based on kilograms per meter cubed. However, we generally see that in grams per milliliter or grams per centimeter cubed, simply because the quantities we're dealing with are smaller. There are other derived units. These are the ones that we see most often. What is the base unit for mass? Whenever we're talking about mass and when we use the SI base unit, we're going to talk about it in terms of kilograms. So grams is also a way to measure the mass, but if we want to use the base units, we need to put it in kilograms. Moles measures the amount of substance, and we'll learn more about moles later on in this course. Now we're going to look at metric prefixes, and these are modifiers that we can use in front of another unit in order to change the number associated with that, but not actually change the value or the measurement. So for example, instead of talking about a very large number of meters, it might be easier to have a smaller number of kilometers. But because there's a relationship between kilometers and meters, it means the same thing. It's the exact same measurement. It's just a different way of expressing it. And we're going to talk about base units a little bit differently here. So we have the SI base units, which are the accepted units for any individual quantity. When we talk about a base unit here, what we're really talking about is things like grams, liters, meters. So these are base units that we use metric prefixes with in order to modify them. And it doesn't matter what prefix we put in front of something, whether I have kilograms or kilometers, the prefix kilo means exactly the same thing every time. So we have a kilo, which has the abbreviation K and the meaning of 10 to the third. So what we're saying is that's the same as 1 times 10 to the third, or 1,000. And the reason we do this is just to make numbers more convenient to handle, so that we're not dealing with really, really small numbers or really, really large numbers. And there is a series of prefixes, and this is going to be some of these you have to memorize, and I'll show you where that list is at the end of this lesson. Let's look at another prefix, milli, which has the abbreviation M and the meaning of 10 to the minus 3. So that would be the same as 1 times 10 to the minus 3, or 0.001. And we'll talk a little bit more about scientific notation just a little bit later. But when we look at this, we see we have a very small value here. So sometimes it's just more convenient to say we have 1 millimeter instead of saying we have 0.001 meters. The less zeros there are, the less likely we're to have a transcription error. One more prefix we need to look at is micro. And when we look at micro, we see that it's the Greek letter mu, which is its prefix. Many times you're going to see mu written as MC instead. And this is particularly true in healthcare because when you write the Greek symbol mu, it's very easy for that to be confused with the letter M. And there's a big difference, in fact, a 3 order of magnitude difference between microliters and milliliters. So when you see either mu or the MC as a prefix, those both mean micro. Microliters and milliliters are not equal to one another. So if I want to think about this in terms of scale, 1 milliliter is equal to 1,000 microliters. If I look at my diagram over here on the right, there are 1,000 squares there, and the red box represents 1 microliter out of the 1 milliliter. So remembering that mu and MC represent the same thing, and they are not the same as the prefix M. What is the meaning of the prefix milli? Milli means 10 to the minus 3. 10 to the third is kilo. 10 to the second is hexo, not one we see very often. And 10 to the minus 2 is centi. Which one has the largest volume? The correct answer here is C, 100 milliliters. When we look at 100 mcl versus 100 μl, those both represent microliters, so those are exact amounts. We know that 1 microliter is much, much smaller than 1 milliliter. Therefore, 100 microliters will be much, much smaller than 100 milliliters. There are some metric prefixes that you will need to memorize because they're ones that we use most frequently. If you go to Canvas and look for the link to course details, and then look for the page that says concepts to memorize. On that page, there's a table of metric prefixes that you're responsible for knowing the name, meaning, and abbreviation.